I'll go straight into it. I've got three great panel members with me, starting to my left with Michael Ford from Aegis, Robert Huber from Mentor and a Siemens company, and then David Greenman from Humiseal. Welcome. Now, what are the sort of trends you're seeing in the market, and how's that driving the development of the solutions you offer?
The biggest trend is coming from the changes in world politics, if you like, or the way the world is structured. People's appreciation of risk of making products in remote geographies. People are looking for alternatives to that. It's not as simple as it was once, where you would consider the costs of labor or the costs of shipping. Now you have to think, if I am manufacturing locally, what does my manufacturing company need to look like if I am going to be surviving, competitive? Where's my competitive edge going to be? Where's my differentiation going to be? So those kind of companies are now coming to us as solution providers to say, look, Industry 4.0, it's great in theory, but reports have shown that less than 5% of companies have actually adopted it. Was that the 5-year plan of Industry 4.0, just to get 5%? No, it wasn't. So what are we going to do to provide the solutions? Now, in parallel with that, we've been quite fortunate in seeing the development of digital standards to connect machines together, to provide an environment where we can start to share data. In parallel with that, we've seen the advancement of analytics, where we can start to use that data to start to create value. So we are right now at that point where we can see the emergence of true Industry 4.0. And that's not just coming from one software vendor or another, it's coming from machine vendors, it's coming from all manner of providers, all now cooperating to deliver on this dream from 5 years ago.
Interesting you say dream. So dream also now turning into reality. Is that something you would agree with?
Certainly we are seeing more involvement in Internet of Things. People are coming to us with problems of putting boards into environments where they need the protection, which is obviously where we come in with our conformal coatings. So certainly we're seeing more and more requests for protection of boards in very different environments than we dealt with before.
Yeah, for me, one of the biggest trends that, let me explain the implications of that, is the lot size 1. We have in the meantime many customers that are down at lot size 1 or 5 or 10 or whatever, but the implications are massive, because what that means is not that you produce less, it's the variations that they build. And now the question is, how many prototypes do you want to build? For each variant, a prototype, you could not afford that. Time would be too slow. So you need to start with this whole digital twin of the product itself, or the simulations, vibration, signaling, DFM, flow therm, and so on. All this is important to simulate. But then you go also into production. So what we see in these areas, additive manufacturing plays a major role. To be much faster. I mean, we have now printed circuit boards. You can just print. How fast are you? You design, you print, and an hour later, you build your first prototype. When you go into analytics, you have to go to process-based analytics. Product-based analytics, you wouldn't get enough data. So you have to have process-based analytics with all the engines, smart data behind. Big data is just a lot of data, but you have to have artificial intelligence and smart data to drive the decision and bring everything back.
But that's sort of the key. Now we're looking at all this data. There is a lot of data floating around, and it, to me it's how to analyze it in a way that produces the results. And that to me also seems that we need to change the way we traditionally are working as a equipment vendor or a solutions provider to be able to deal with those sort of new challenges that are coming around. What are those new challenges that we're facing?
They are the old challenges, to be fair.
Okay.
Like a few years ago, you go up to any machine in the industry and you take out a report, and you realize that 80% of the data is garbage. And it's not the fault of the machine. The machine didn't know why it was starved. It doesn't know why its output is blocked. So you need, first of all, I mean, with the Connected Factory Exchange, we've standardized the way in which data is transmitted. This gives you the opportunity to start to talk to more than one machine. Now, machine vendors have been doing this in lines for many years. They control all of the machines in the line, that's fine. But with Connected Factory, we can look at the whole process. So, for example, a machine has stopped. Why did it stop? The previous machine stopped. Why did that stop? The previous machine had an issue with material. What was that issue? Was it moisture sensitive? Was it a damaged reel? What was it? So you're building up a layer of context. So not only are we improving the value of the data, but we're building the context of that data. When you then utilize that data in our artificial intelligence environments, whether it's generated by a machine vendor, solution provider, or even a cloud provider where they're looking at long-term statistics, all of that information has value. And so that is the critical point for people to understand about the analysis of the data. Because also you need to bear in mind, in a high-mix factory, the machines aren't even working most of the time. So you've got no data to analyze from the machine. You need to interpret the data between processes in order to work out why is that machine not working. And so this is the layer that a modern digital MES will do in real time to be able to understand exactly what's happening and be able to provide assistance then.
And Robert, you now have to obviously rely on the data coming from the equipment vendors and work with them in a way, and Michael touched on the standards question or issue, if we call it, there are standards in place, but where are we along that journey, and how are you having to work with equipment vendors? And then my question will be to you as to how is that two-way information now being organized, I suppose?
Yeah, so in general, we were in a business to connect the machines for so many years. And of course, we have done this before. A standard, of course, makes our life much easier because today we support 300 machine interfaces. And to maintain that, it's a lot of work. If everybody comes with the standard, it makes our life much, much easier. But the question is always the quality of the data you need, right? Is it sufficient? Is it just basic data? Or does it give you real insights, which is really important? And one of the things that we feel very, very important is you need to compare the data with your expectations. So we always believe in the digital twin of the product and of the process and what you collect. You have to fine-tune your models because that's your prediction. If you plan for 7% utilization, you achieve 7% utilization, you're doing great. If you just measure 7% utilization, you don't know is it good or bad because you need always to compare against plan. And I think so it's, for us, it's very, very critical that you bring these worlds together. The virtual product, the digital twin of the product, the digital twin of the process, with the digital twin of the production, with the output, and fine-tune the models in order to improve better what you achieve.
So as Michael was saying, some of these machines are not working 24/7, but when they do start working, they want the data to be able to be collected and flowed. That is where our protective coatings come in. That's where we come in. With the modern day packing density of printed circuit boards with surface mount technology, they're more prone to fall over if they're in a high humidity or a bad environment. And a protective coating can help them to deliver that data when it's required without failing.
This is the interesting thing about this data exchange because machine vendors like yourselves have been pressured for many, many years to deliver data. I mean, it's what you said, 300 machine interfaces. Each machine vendor has 30 or 40 interfaces they're supporting. It's an absolute nightmare to record the critical data that you produce in order to provide the traceability data required by your customers. So what's in it for the machine vendor? And so having the connected factory means that data goes in all directions. So we provide data for the manufacturing areas to give them a heads up on what's coming down so that you can adjust and optimize your processes in line with the changing customer demand, which Industry 4.0 is driving. So this is how the whole thing is becoming sustainable. And it's involving absolutely everyone. So, you know, we're working with, or we're seeing from IPC standpoint, literally hundreds of machine vendors now, all asking the same questions. Okay, we understand the data requirements. It's very simply defined in the standard, but how do we make this work for our customers? Because that's what the trend is really demanding.
Yeah.
It's enough to talk about bits and bytes, but let's talk about value for the customer.
And that's the stage we're at. I'm going to have to wrap this up because the 50 minutes are already over. But really, it comes down to the dream that we had 5 years ago, plus actually has now turned into reality. And it's great to have you here on the panel. Thank you very much for your contribution. Thank you very much to the audience for listening. And I wish you a successful show here as well in Nuremberg.
Thank you.
Thank
Thank
you.
you very
Thank you.
much.